Before we begin, listen carefully. The F-22 Raptor's invisibility isn't in its shape. It's not in its wings. It's not in its angular silhouette. It's in something almost no one understands, and that is never explained in detail. Its skin. Stay until the end, because you'll understand why this technology not only remains secret, but why copying it today would be nearly impossible, even for the world's greatest military powers. What if the F-22 Raptor's true invisibility wasn't in its shape, but in something far more complex? Its skin. For years, the F-22 Raptor has been presented as the most advanced fighter jet ever built. Its angular silhouette, its supercruise capability, and its absolute airspace dominance have made it a modern myth. However, most public analyses have focused on its aerodynamics and avionics, neglecting the most critical and least understood element of its design: the external coating that makes it virtually invisible. If you're interested in these kinds of stories where engineering and history intersect, subscribing right now is the best way to make sure you don't miss the next analyses. Technical documents and engineer testimonies reveal that the F-22's true secret lies not only in its stealth design, but also in a complex, multi-layered skin designed to absorb, scatter, and distort radar signals. This surface is neither ordinary paint nor a simple absorbent coating. It is an active and passive system that functions as an electromagnetic barrier. In the 1990s, when the Advanced Tactical Fighter program entered its crucial phase, engineers faced a fundamental problem. Stealth alone was insufficient. Modern radars were beginning to operate on multiple bands, capable of detecting even aircraft with optimized geometries. To maintain air superiority, something more was needed. And pay attention, because in a few minutes you will understand why this promise ultimately became a problem that no one could ignore. The solution was radical: to develop an advanced composite material capable of interacting with radar waves at a microscopic level. This skin would be composed of superimposed layers of polymers, ceramics, ferrites, and conductive materials, each with a specific function. Some absorbed electromagnetic energy, others deflected it, still others converted it into dissipable heat. Unlike earlier stealth aircraft, such as the F-117, the F-22 did not rely solely on fragile and difficult-to-maintain coatings. Its skin was designed to be structurally integrated with the fuselage, reducing the need for constant maintenance and increasing durability in actual combat. Reports indicate that each F-22 panel has a slightly different composition, optimized for its location. The wings, forward fuselage, and air intakes all feature variations in material to respond to different angles of enemy radar incidents. In other words, the aircraft is not uniformly invisible. Its invisibility is calculated. One of the most surprising aspects of this invisible skin is its ability to adapt thermally. At supersonic speeds, the heating of the fuselage can alter the electromagnetic properties of the materials. To prevent this, the F-22's coating includes layers that regulate temperature and maintain a stable radar signature even during extreme maneuvers. The program engineers, they described this system as smart armor. It doesn't actively detect enemy radar, but it's designed to function optimally in a sensor-saturated environment. Each layer serves a precise function, and the failure of even one can increase the aircraft's detectability. Initial tests were conducted in large anechoic chambers, where the F-22 was exposed to a variety of radar frequencies. The results surprised even the developers themselves. In certain configurations, the aircraft was virtually indistinguishable from the background noise. However, this technology came at a high price. The F-22's invisible skin was extremely expensive to produce and required highly specialized industrial processes. Each aircraft required thousands of hours of labor just to apply and calibrate the coating. This significantly contributed to the program's high cost and the Raptor's limited production. Let's pause here to invite you to like and subscribe to the channel if you enjoyed this. You're enjoying the video so far. After this pause, the documents reveal an even more sensitive aspect. The F-22 skin not only reduces its radar signature, but also protects its electronic signature. The aircraft's internal emissions, sensors, communications, electronic warfare systems are contained and channeled to prevent detectable leaks. This makes the F-22 more than just a stealth aircraft. It's a platform designed to operate in electromagnetic silence, attacking undetected and withdrawing before the enemy even realizes what has happened. This question has been analyzed for over 2 decades in military and scientific circles. Although several countries have developed stealth aircraft, none have achieved the F-22's level of complete invisibility. The reason lies not only in the aircraft's shape or software, but also in the extreme complexity of its external coating and the industrial ecosystem required to produce it. The F-22's so-called skin is not a single material but a highly specialized, multi-layered system. Each layer serves a distinct function and is designed to interact with different radar wavelengths. The outer layers absorb some of the incoming electromagnetic energy. The intermediate layers scatter it in multiple directions, and the inner layers prevent the signal from reaching critical metal components that would act as reflectors. Unlike traditional absorbent paints, the F-22's coating is structurally integrated into the fuselage. This means it cannot be applied as a simple surface layer. It is part of the fuselage itself. The aircraft's skin has been a source of great refinement since its manufacture. To achieve this, Lockheed Martin developed unprecedented industrial processes that combined advanced chemistry, nascent nanotechnology, and extreme quality control. One of the biggest challenges was microscopic uniformity. For the skin to function correctly, the thickness of each layer must be kept within extremely tight tolerances, measured in microns. Even a minute variation can alter the material's electromagnetic response and increase the aircraft's radar signature. This necessitated the creation of entirely new production facilities, inaccessible to most of the world's aircraft manufacturers. Furthermore, the F-22's skin is designed to withstand extreme mechanical and thermal stress. During high-G maneuvers and sustained supersonic flight, the fuselage deforms slightly and heats up unevenly. Conventional materials would lose their stealth properties under these conditions. The Raptor's coating, however, maintains its stable electromagnetic behavior even under these stresses. Another key aspect is the management of the seams and edges. In most aircraft, the seams between panels, screws, and leading edges are weak points from a stealth perspective. In the F-22, these areas were redesigned to form seamless transitions, covered with flexible, absorbent materials that prevent unexpected radar reflections. Engineers also developed specific treatments for the air intakes and exhausts, traditionally the most radar-exposed areas. This invisible skin works in conjunction with internal S-shaped ducts and heat-resistant coatings that reduce both the radar and infrared signatures. This allows the F-22 to approach targets undetected by either radar or conventional thermal sensors. This complexity explains why copying the F-22's skin is not simply a matter of industrial espionage. Even with blueprints or samples, reproducing the system would require an industrial infrastructure comparable to that of the United States in the 1990s, in addition to decades of accumulated expertise in advanced materials. Attempts at replication by other powers have resulted in only partial solutions. Some modern stealth aircraft use advanced radar-absorbing coatings, but these tend to be more fragile, require more maintenance, or lose effectiveness in certain radar bands. In contrast, the F-22's skin was designed to be operationally robust, capable of withstanding prolonged deployments without compromising its stealth. Technical documents also reveal that the F-22's coating was conceived as an evolutionary system. Throughout its operational life, incremental improvements were made to the material composition, adapting it to new types of enemy radar and sensors. Upgradability is another factor that has kept the Raptor ahead of his adversaries for years. From a strategic standpoint, the F-22's stealth skin not only reduces its detectability but also changes the dynamics of air combat. By being able to operate within enemy airspace undetected, the aircraft forces defensive systems to react late or incorrectly. This multiplies the effectiveness of their sensors and weapons, even before a single missile is fired. For years, it was claimed that stealth technology was obsolete due to the advent of low-frequency radars, passive sensors, and multispectral detection systems. However, actual operational data tells a much more complex story. The F-22 Raptor remains, even decades after its first flight, one of the most difficult aircraft ever built to detect. And the primary reason remains its stealth skin. Unlike other stealth designs that rely on piecemeal or specific solutions, the Raptor was conceived from the outset as a comprehensive stealth system, where structure, materials, and electronics work as a single entity. Defense experts point out that the F-22 skin wasn't designed to fool just one type of radar, but rather to drastically reduce the overall probability of detection. This means that even if certain sensors can detect an anomaly, continuous tracking and accurate identification are extremely difficult. In actual combat, that difference of seconds or minutes is decisive. Over time, the technology evolved, but so did the F-22 itself. Declassified documents indicate that its coating has been upgraded multiple times. New absorbent materials, improvements in thermal stability, and adjustments to the electromagnetic composition have allowed the invisible skin to remain effective against modern multi-band radars. Another crucial aspect is integration with passive systems. The F-22 doesn't rely solely on its stealth. It also actively minimizes its electronic emissions. Its skin acts as a barrier containing internal signals, preventing enemy sensors from detecting unwanted emissions. This makes the aircraft an extremely difficult platform to locate, even without using active radar. In joint military exercises, the F-22 has consistently demonstrated its ability to penetrate advanced air defenses undetected. While many of these results remain classified, official statements from pilots and commanders confirm that the Raptor often sees without being seen, a tactical advantage that remains virtually insurmountable. The strategic impact of this technology extends far beyond the F-22 itself. The experience gained with its stealth capabilities has directly influenced the development of new programs, such as the F-35 and future sixth-generation fighters. However, no other aircraft has exactly replicated the Raptor's approach. In many cases, cost and ease of maintenance have been prioritized over the extreme complexity of the F-22 skin. This has led some analysts to claim that the Raptor represents a unique technological peak, a point in history where stealth was pushed to its absolute limit with the available resources. Replicating that level today would require colossal investments and a highly specialized industrial infrastructure. Furthermore, the F-22 skin has yielded key lessons for the future of aerial warfare. And now that you understand why this technology disappeared despite its functionality, if you want to continue exploring the secrets of aviation, military engineering, and the stories that aren't always told, subscribe to the channel and turn on notifications so you don't miss the next videos. Because in aviation, as you've seen today, it's not always the most spectacular that survives, but the most efficient.